So where we left off last time, I just want to kind of go over the aggregation real quick. And that aggregation means we are going to, as part of our instance variables, we're actually going to use objects for our instance variables. So in this case, remember we had an instructor class, and we're going to create an instructor object. It's got the last name, first name, office number. And we have a textbook class, and we're going to create a textbook object which has title, author, and publisher. The course, on the other hand, is going to have objects brought in. So we're going to have an instructor object and a textbook object. And in our constructor, we actually bring in an instructor object, INSTR, and textbook object, which is text. We go ahead and the course name is a string. We go ahead and load that instance variable. And then what we do is we do instructor equals new instructor and then INSTR. What that does, that creates a new instructor object. And that instructor object is just for this class. Same way with the textbook. Now if we look at the book talks about this thing called a shallow copy. And what that means is this. So let's say we did this instead. We've got our public course, string name, instructor, INSTR, and textbook text. And down here I just said instructor is equal to INSTR and textbook is equal to text. Now it's going to work, but the only problem is, if you remember, when I make an object equal to another object, all that does is create a new name tag. They're both pointing to the same exact object. And here's where the security issue is. This INSTR right here is accessible and modifiable outside of this class. So this instructor we don't have total control over. It actually can be controlled outside of this class. So instead what we do is we create a new instructor. We instantiate a new instructor object. That way there we have total control over this instructor, whereas this one over here we do not have total control over. Same way with the textbook. And that's kind of what they talk about on page 525, is this is the proper way to do it, is we basically say return new. Another security issue is when we return an object. If we look at what we do down here in our get and our getter, we create a new instructor object and return that. That new object is going to be separate from the instructor that we have. And what that will do is that will make sure that, again, we have two separate instructors, one that we control and then one the outside class who basically calls this object controls. If we just returned instructor, guess what? We've now given some other class access to our instructor inside our class so that it can change and modify that particular item outside of us. So again, what they say here is it causes a security hole. It's actually called a shallow copy, and we don't want to basically do that. So when we're doing aggregation, make sure we seal up those holes. We basically leave the things very secure, and we don't let outside classes have access to our class that we're trying to do. Does that make sense? The next thing let's take a look at is the full name. Let's open up full name, and let's talk about the issue here. So here's a full name class. I've got 3 instance variables: last name, first name, middle name. They're all strings. We don't have any constructor. We then have our setters and we have our getters. Well, in this case, all we have is one getter. We've got getter, get length, and let me do this real quick. I don't want to do this. I want to. So this is what they have in the book. So get length, we're just going to return last name dot length plus, or concatenate. We're going to concatenate first name dot length, and then, okay, I'm sorry. In this case, we are going to do an addition because this is a numeric. So it's going to grab the length and add the first name length and add the middle name length. And it's going to return that. Well, let's take a look at name tester. And we have int length, so we got a variable len, and we say full name equal. We're going to instantiate a new object called name from full name, and it just gets instantiated. And then we're going to say len equals name.getLength. We could even do something like this. I could do an SYSO, and let's just go ahead and print len in there. So we'll print len. But here's the issue. Let's run it, and boom, we get an error that says can't invoke string.length because last name and full name and name tester, they're null. There's nothing in them. We never did anything with, we never set the length to anything. So what the book suggests that we do is we do this. Comment this out and uncomment this. Is we do this. In our get length, we go ahead and create a variable called len. We set it to 0. And then we say if last name not equal null, then we're going to take the len plus equal last name.length. We're going to add that to len. We're going to do the same thing for first name. We're going to do the same thing for middle name. So when we get done, if there was anything in those different instance variables, it's going to add the length of that to len. And then we return len. Now, if all these are null, which they're going to be, it's going to return a 0. So it's going to work this time. So now when I run this, I go over back to name tester and I run this, it returns a 0 because nothing was set in those instance variables, so the length got set to 0. So the whole point of that is to make sure that when we do, like say for this example, we're trying to get the length of something, always think in the back of your mind that this could be a null value, and this is going to cause an issue because if we try to return the length of something and it has a null value in there, that's going to cause an error. So instead we would have to code around it like with this. I think this is on page, this is on page 528, this example right here. So again, kind of a nice way to make sure that we code around so that, one of the things I've talked about is, and I've probably said this before, is users are the stupidest people on the face of the earth, and we have to code around them. If we want them to type in a numeric value, 1 time out of 10, they're always going to put in an alphanumeric. If I ask for enter the dollar amount, they're going to enter a $sign. And we have to code for that. We have to code for that $sign. We have to be able to kind of foresee every error that the user is going to do, and this is one of them. They might not set a full, for example, not everybody has a middle name. So somebody has a first name and they have a last name, they don't have a middle name. Well, this would basically cause an issue as well because it's a null value. So again, we have to code around that. Does that make sense? Yep, good. On page 529, again, they reiterate the whole this to overcome shadowing so that, like say in my textbook over here, I could put this dot title and this dot author and this dot publisher. And the this always makes sure that, hey, it says we're talking about this class right here, this object, and we're talking about this instance variable. So if I were to do something like this where I had so I have title. Well, this is title and this is title. If I didn't have this, it would think that all these titles are pointing to the same thing. So in order to get around that, we always do this dot, and that will basically always make sure it's pointing to that instance variable, so that when this comes in with the same exact name, this variable is going to match up to that variable, and we can then load it into the instance variable. So again, I've talked about that before, but they just kind of want to reiterate that to make sure we always use this to get over the what they call shadowing. Yeah, another thing that we can do on page 530, when we talk about the stock class, we could have done something like this. I could have had a constructor that looks like this. Let me show what that looks like. And where it's going to have a string. I'll just call this text. We're just bringing in a string. So instead what we're going to do is we're going to say this, and then inside the parentheses we'll say, let's leave a symbol. Sim, comma, 0.0. That should take care of price. Is that price is a double, right? Yeah. Oh, I gotta put a comma there. There we go. So I've got the word this in here, and it says, hey, we're talking about this class, this particular object, and we know that we've got two variables, and it's going to the first one's going to be whatever that is, which is a string, and the second one is a double, so they're separated by a comma, so automatically brings a symbol in and puts that into the symbol instance variable, and then the 0.0 automatically gets put into the share price instance variable. So another way to basically handle just bringing in, let's say, one item, but we have to make sure we load both those instance variables. So we can just say this with the parentheses, and then basically for each one of these. So if there was 3 instance variables, I could do something, comma, something, comma, something. So just another way to use the word this. Okay, this next part of the chapter is I kind of call it the weird part of the chapter, because this enumerated types is it's kind of cool to have, but it really doesn't. To me, it doesn't jump out as something that really makes a lot of sense. But just be aware of that. So let's do this. So enumerated data types consist of a set of predefined values. So that means they already have the values in there, and we can just basically use the enumerated data type name to get that value. So let's just take a look at one. Probably be easier. Let's look at enum demo. So right off the bat, we see this thing called enum. Enum is a reserved word, and we're going to create a enum object called day, and inside the braces are these 7 words, Sunday through Saturday. You'll notice that they are all uppercase, and on the bottom of page 531 it says, when making names for enum types, it's not required that they be written in uppercase, but because they represent constant values, the standard convention is to write them in uppercase. So these are considered constants. So we always write the constants in uppercase. So this is how it works. I've got this object called day. It's an enum data type. It's got these 7 items inside of it. Then I come down here and I can say day, work day. So I'm creating a new day object. So I'm creating an object from this day, and it's going to be equal to day.Wednesday. And then when I say print out, print ln workday, it's going to actually print uppercase Wednesday. Now, enums are they're kind of sort of like an array in that each one has a numeric value. Sunday has a 0, Monday 1, 2, 3, 4, 5, 6. And that in an array we call it the index. In an enum we call it the ordinal value. O-R-D-I-N-A-L, ordinal value. So what we can do is I can say the ordinal value for day.Sunday is day.Sunday.ordinal, and ordinal is a method, so it basically has left and right parentheses. We can do the same thing for Saturday. Then I can say now here's what's kind of, let's do this. Let's just run this real quick, and I'll talk about this if statement in a second. So when we run it, we see that this first one says print workday, and it printed Wednesday. I said print the ordinal value for day Sunday. The ordinal value for Sunday, just a day.Sunday, so it comes out Sunday, is 0. The ordinal value for Saturday is 6. So day.Saturday.ordinal is 6. So down here, let's take a look at this. So now we're going to use the comparative. We've seen this before when we use strings. It's going to compare this Friday. It's actually looking at the ordinal value, and it's going to compare it to day.Monday. If they're equal, the compare will return a 0. If Friday is greater than Monday, it's going to return a positive 1. If Friday happens to be less than Monday, it's going to return a negative 1. So this compare statement is going to return either a 1, 0, or negative 1. If that compare is greater than 0, and it should be because Friday is that is a 5, and Monday is a 1, so 5 is greater than 1. So that's going to return a 1. It's going to print day.Friday is greater than day.Monday. Else, it's going to print day.Friday is not greater than day.Monday. But we can see down here it says Friday is greater than Monday. So basically that was basically true because we know that the compare to statement is greater than 0 because it returned a 1. So enums, again, I think they're kind of weird in the sense that they really don't jump out like, they don't make a whole lot of sense, but just realize that they're constants that are stored in this, this data type called enum. And again, we call this day. So let's do this. Let's open up car type, and here's how we can use them as separate files. So here I've got this separate file called car type, and all it's got, this is all it's got inside there is enum, car type, Porsche, Ferrari, and Jaguar. Again, we always make sure they're inside of braces, and then they're separated by commas. If we open up car color, again, the only thing that's in there is enum car color, red, black, blue, and silver. So we're going to open up, I think it's the sports car. So let's open up sports car. And there we basically have created a class sports car. It has 3 instance variables. The first one is car type make, car color color, and double price. Notice that this is now a data type. Car type is now a data type, and car color is a data type. So when I have my constant, or I'm sorry, my constructor, we're going to bring in the car type, the car color, and the double. So it's going to be called a make, a color, and a price. And we're going to set each one of the instance variables to make, color, and price. We got get make, it's going to return make. Look at, it's returning a car type. Car color, it's going to return color, and again it's returning the enum car color. We got get price, it's going to return a double. We've got our toString. So if we basically say print, this is called sports car. If I say print sports car, or that sports car object, it's going to basically automatically execute the toString. So we have a decimal format dollar. So we got a dollar object. It's just set to, it's going to have thousand separator and then 2 decimal places. My string is going to be make. It's going to show the make. And then it's going to new line color, and it's going to display the color. And then the new line price $sign, it's going to basically format it. It's going to format the price into that format right here. We return the string. So let's take a look at sports car demo. So here's our public static void main. Here we create our sports car object. It's called your new car, and it's instantiated as a new sports car, and we're going to have car type Porsche and car color red, and it's 100,000. And then I just say print your car. That's going to call the toString and automatically print out that big long, those 3 lines of text. So let's run it. And there it is. Make is Porsche, color is red, and the price is $100,000. Notice we got the thousand separator, and it's rounded to 2 decimal places. So if we've got some things that we know, the different values that we're going to need, like sets of colors, maybe job titles, all those types of things, we can put those in enums so they're there so that we can just utilize them. They're always there. And what's really nice, they can be separate files all by themselves. So someone can maintain this file, and all they do is maintain all the different the values of in this case, the different car types. If we take a look, any questions before we go on? Okay. If we take a look at Sports Car Demo 2, so same thing. This time we basically we created a sports car. It's a Porsche. It's red, and it's 100,000. Now we're going to use a switch statement. We could have used an else if statement. So switch case, your new car dot get make. So it's going to call this sports car, and it's going to call the get make. Again, it's expecting a car type. And it says case Porsche. It's going to print your car was made in Germany. Case Ferrari, your car was made in Italy. Case Jaguar, your car was made in England. And the default, if it's not any of those, it's going to print, I'm not sure where your car was made. And then it's going to print your new car, which again calls that toString and prints those 3 lines of code. So when we run it, it says your car was made in Germany, make Porsche, color red, price $100,000. Okay, any questions? On page 810, let me see if I can get there faster. I'm sorry, 540. Man, my eyes are bad. 540. We've got this thing called garbage collection. Now, what's nice about garbage collection is we never have to worry about it. Our Java virtual machine, or JVM, automatically takes care of this for us automatically. So it says the Java virtual machine periodically runs a process known as garbage collector, which removes unreferenced objects from memory. So what it does is it goes through and says, okay, your sports car, you're not using an object anymore. It goes ahead and cleans that up and removes it from memory. And all those different classes that we made, all those different objects, when they're no longer used. Now again, we don't know when garbage collection is going to run, but it's going to run at some time, and it's just going to automatically remove all those objects for us automatically. So for example, we have bank account, account 1, account 2. We go ahead and instantiate account 1 with 500 starting balance. Account 2 is equal to account 1. And then I say account 1 is equal to null. Now what it does is it takes that particular object and nulls it out. So what happens at that point, somewhere after this line right here gets executed, the garbage collection will run. Again, we don't know when, but it will. But then when it gets to this account 2, don't know, but account 2 will stay active. Account 1 will be null, account 2 will be active, and then when we make it null right here, then the garbage collector will know, oh, it's no longer used, and it's going to go ahead and it'll wipe it out of memory. So kind of here's what it looks like in graphical. So we basically create our bank account object. It's got 500 in balance. I make account 2 equal to count 1. So both of these objects are pointing to the same object in memory. When we get done, when we make account 1 equal null, we basically break that. Like the bank account object for account 2 still exists, but account 1 doesn't. The garbage collector, again, can come along and wipe out this particular object, this reference to the object. And then when we make account 2 equal null, that no longer points to that. So now this reference to the object can be wiped out, and this object's no longer used. So guess what? It's going to be removed by the garbage collection. Now, what's really nice is we do have a method that's automatically built in, and we can utilize it. It's called the finalize method. If a class has a method named finalize, it will automatically be executed just before the class is destroyed. Okay, so maybe we want to clean up some files. Maybe we want to close that file. Any type of cleanup that needs to happen, we can put in that finalize method, and just before the garbage collector actually runs to clean up that object, that finalize method will automatically be ran and do whatever we need to do at that time within there. So the garbage collector runs periodically, and you cannot predict exactly when it will execute. Therefore, you cannot know exactly when an object's finalize method will execute. So any questions on garbage collection? What's that? It's pretty. I mean, like I said, it's kind of a nice feature. It's built in. We don't have to worry about it. It just automatically runs and cleans things up, and life is good. Focus on object-oriented design and class collaboration. It says it's common for classes to interact, collaborate with each other to perform their operations. Part of the OO design is identifying the collaborating classes among classes. So if we take a look at the very last, if we go in here to Eclipse and the very last stock purchase, let's go ahead and expand the stock purchase package. And if we take a look at stock, there we've got our two instance variables, the same instance variables we've seen throughout this whole chapter. We've got string symbol and double share price. Here's our standard constructor. We bring in symbol, we bring in price, we load those two instance variables with whatever is passed in those arguments. We have a stock, we have a different stock object or a stock constructor, and then we're just bringing in a stock object. And so what we're doing is we're grabbing the symbol off of that object and throw it in the symbol. We're grabbing the share price off that object and throw it in the share price. Again, we want to separate ourselves from this new stock object 2 coming in. So instead of just basically create a new stock object and make it equal to the other object, we don't want that to happen because this object 2 we don't have any control over. It's controlled outside of this class, so we're just going to grab the two instance variables from this object and make them equal to our instance variables, and now we basically have our own object. We've got our get symbol, we've got our get share price, and here's our toString where it's going to basically create the trading symbol and display the symbol, new line share price, and we return that string. We do have an equals. We're going to see if the symbol is equal to object, so we're going to pass in another object. We're going to see if that symbol equals the object pass in symbol, and the share price is equal to the share price. If those two are true, it's going to return true, else it's going to return false. We have a stock copy, so if we needed to make a copy of a stock, we can basically say stock copy object equals new stock symbol and share price. So this is going to return a stock object, because right here it says stock. It's going to return a stock object, so it's going to return a new, sort of instantiate a new stock object with the same symbol and share price to whatever calls this particular method. So if we look at stock demo 1, pretty straightforward. We instantiate a new stock object with XYZ and 9.62. We say print the stock object, and it's going to automatically call the toString and print those two lines of text. We've got stock purchase. Now this is another class that's being brought in. So we've got stocks, and now look at this. We're doing some aggregation here. We've got a stock object as an instance variable. We've got int shares. Here's our constructor. We bring in a stock object. We bring in the number of shares. Look at this. We're going to instantiate a new stock object from the object brought in. Again, we always want to do that so that we have control over this object inside of our class, because the stock object is made somewhere else and somebody else has access to that outside of this class. We then make num shares equal shares. And then we got get stock. That's going to return a new stock object. Again, we always want to return a new stock object, so whoever gets this has their own stock object and it's not affecting this stock object that we are currently in. We got get shares, return shares. We got get cost. That's going to take the number of shares and multiply it times the stock share price. Now you notice we said stock.get share price. Could I have just done this? Yep, that's going to work. That should work. Apparently it doesn't. No, apparently it doesn't. Okay, I would have thought that would have worked because we're talking about, or could I have done this? I could have said, oh, I'm sorry, we did. I'm confused. I thought we were in stock. No, this is stock purchase. So yeah, we have to get the stock dot price. Yeah, we have to call the stock dot get price. Yeah, my bad. Yeah, we don't have, all we have are stock and shares. So we're going to basically, whatever stock is brought in, I'm sorry, I was confused. So what we're saying is take the number of shares that we have in our instance variable, and then take the stock, which is also an instance variable. I should have known that since it was blue, and then dot get the share price, and that's going to return a double, which is going to be a price of the total number of shares that we have multiplied times the price. So that's the purchase. If we look at stock trader, this is our instance variable. We got int shares to buy. We create a stock object. It's XYZ 9.62. We got our scanner keyboard. I wanted to say XYZ stock is currently, and we're using a printf here, and we're going to get the share price. It's going to return, so it's going to print that. and this percent, so it's dollar. It's basically a comma, thousandths comma separator, 2 decimal places, floating decimal point. And how many shares do you want to buy? And we get that from the user from the keyboard next int. And then we say stock purchase buy. So now we're creating a new stock object called stock purchase called buy. It's instantiated using the stock object itself, the aggregation, and the number of shares to buy. And then we're going to say the cost of the stock, and again we're using a printf here, and buy.getCost. So we basically call this stock purchase, and we use this get cost, and we basically get that brought in there. So when we run this, we come up here, and this is a stock. XYZ stock is currently 9.62. How many shares do you want to buy? Let's just make it easy. We're going to say 20. And the cost of the stock is going to cost us $192.40. We could have made it really easy by just doing and buy 10 shares. That's 96.20. So the whole point of that is how we use aggregation to basically, in this particular case here, we created a stock object, and then we've used that stock object to create a stock purchase object. And then inside of the stock purchase, we're actually calling a method inside of the stock class right here. Any questions?